Right now, this second, the universe is dying. Not with a scream, not with fire. Slower than that, so slow you will never notice. So slow that everyone you love and everyone who has ever lived will be gone long before it finishes. But it has already started, and physics is fairly certain. It cannot be stopped. There are at least 5 ways this ends. Some take 100 billion years. Some take 100 trillion. One of them could happen in the next second, anywhere in the universe without warning. Tonight we rank them, not by drama, but by what the evidence actually says. And what physics tells us is unsettling. In 1998, 2 teams of astronomers pointed their telescopes at exploding stars, at supernovae billions of light years away, expecting to measure how much the expansion of the universe was slowing down. Gravity, after all, pulls everything together. It should be putting on the brakes. Instead, they found the opposite. The expansion was speeding up. Something was pushing space apart, and it was winning. They called it dark energy. We still do not know what it actually is. We only know 2 things for certain. It makes up roughly 70% of everything that exists, and it is going to decide how this all ends. Here is the strange part. The fate of every galaxy, every star, every atom depends on a single number we have not measured precisely enough. Physicists call it the equation of state of dark energy, W for short. If W sits exactly at -1, dark energy stays constant forever, and one ending is essentially guaranteed. If W drifts even slightly below that line, a far more violent ending becomes possible. And if it drifts above it, an older, quieter possibility opens back up. We are watching a countdown, and we cannot read all of the digits yet. 5 endings. Let's start with the slow one. The first ending is called heat death, or the big freeze. If dark energy holds steady, space keeps expanding forever, faster and faster, but never accelerating into outright destruction. Galaxies drift beyond each other's light. In 100 billion years, an observer standing in the Milky Way would see almost nothing else in the sky at all, just one island, alone, in a black and silent ocean. Stars burn out, one by one, over trillions of years. Black holes evaporate over spans of time so long, the number barely means anything. Eventually there is no light left, no heat, no motion capable of doing any work at all. Just cold, spread evenly across everything. Forever. The second is far more violent. If W drops even slightly past -1, dark energy does not just push space apart, it accelerates without limit. This is the big rip. Galaxies get torn from their clusters first, then solar systems are pulled apart, then planets. In the final fraction of a second, the expansion becomes so extreme that it overpowers the very forces holding atoms together. Space itself tears every particle away from every other particle. The third does not need billions of years, or even one. Quantum theory suggests that the vacuum of space itself might not be as stable as it looks. It could be sitting in a false minimum, a shallow valley instead of the lowest possible energy state in nature. If we are on the unstable side, a bubble of true vacuum could form somewhere, at any moment, for no visible reason at all. That bubble is only the trigger. What happens next is called false vacuum collapse. Once true vacuum appears anywhere, it expands outward at the speed of light in every direction. There is no warning. There could be no defense. The laws of physics themselves would be rewritten as the bubble wall passed through. Chemistry ending. Matter as we understand it ceasing to exist. All before a single photon could arrive to warn us it was coming. The 5th ending is the big crunch. This is the reverse of everything else. Dark energy would need to weaken, then flip. Gravity would need to win after all. Expansion would slow, stop, and reverse. Galaxies would rush back toward each other, faster and faster, the entire visible universe collapsing back into a single, impossibly dense point. Some physicists have proposed that point could bounce and begin expanding again. A new universe rising out of the wreckage of this one. So which of these is actually happening? Ranked by current evidence, heat death is the frontrunner. Every measurement of dark energy we have made puts W very close to -1, which is exactly the value that guarantees the slow, cold death. Not a violent ending, just quiet, going on without end. But recent observations from telescopes like decay are starting to hint that W may not be constant after all. It might be drifting. If that holds up, the picture opens back up. Big rip, big crunch, both come back into play. Vacuum decay is the one no serious physicist rules out. Calculations built from the measured mass of the Higgs boson suggest our universe may sit almost exactly on the line between stable and unstable. Close enough that physicists still argue over which side we are actually on. The odds of the bubble forming in any given year are thought to be extraordinarily small, but the number's not zero, and it would only have to happen once. None of this happens soon, with one exception. Vacuum decay could theoretically begin tomorrow, or in 100 trillion years. Physics cannot narrow it further. The rest are far away. Heat death takes 10 to the 100 years. The big rip, if it happens, is at least 22 billion years off. The big crunch is even further. By the time any of them arrives, our sun will have burned out. Our galaxy will have collided with Andromeda. Every civilization that ever tried to matter will have been forgotten for longer than the current age of the universe. In a very real sense, the universe has already decided its own ending. We are just the ones trying to read the last page, long before we ever get there.